Hello friends, this is Saman here and we're gonna talk a bit about the mixtures. The mixtures can be classified into three main classes like solutions, suspensions and colloids based on their properties, physical-chemical properties, and mainly based on their particle size. So first of all, we are gonna talk a bit about the solutions. I'm 100% sure that everyone knows about the solutions. Just a bit of explanation. If we add a little bit of salt or sugar in water and stir it gently, what will happen? We are making kind of solution. Why? Because, for example, in the case of sodium chloride or salt, edible salt in water, what will happen is we've got some sodium cations and chloride anions, and sodium cations will be covered with the oxygen head of water with ion dipole interaction. Why ion dipole interaction? Because sodium cation is an ion and water is a kind of dipole molecule, so we've got a kind of ion dipole intermolecular interaction. But why oxygen head of water will cover the sodium cations? It's really clear because oxygen is more electronegative than hydrogen. So in the terms of this covalent interaction, covalent bond here, oxygen will pull the electrons towards himself or herself or itself, whatever you call it. So we've got oxygen with partially negatively charged and hydrogen with partially positively charged here, and there is a kind of electrostatic interaction between this cation and this partially negatively charged oxygen here. And here we've got oxygen, hydrogen with positively charged here, oxygen negatively charged, partially negatively charged, and partially positively charged here. How about the chloride anion? As you can see, we've got an ion here and we've got some partially positively charged particles here. So a kind of electrostatic interaction again happened between this ion and this positively charged particle or hydrogen here. So what will happen if we've got, for example, sugar in water and we haven't got any ion dipole interaction? Because we haven't got any ion here. So in this case, we've got some hydrogen bond or dipole-dipole interaction or whatever intermolecular interaction will dissolve sugar in water. What exactly here is salt is miscible with water. So salt can be completely dissolved very easily in water and make a kind of homogeneous mixture. When we call homogeneous, we mean that a kind of uniformly mixture is happening between sodium chloride or sugar in water. And the main point here is the size, the particle size. When we've got a solution, the particle size is very, very, very small, in the size of atoms or ions or small molecules, which is less than 1 nanometer or 10 angstrom. As you know, 1 angstrom is a tenth of nanometer. So when the particle size of the solution is less than 1 nanometer, we can call it is the size is less than 10 angstrom. And the size of atoms is roughly between 0.1 angstrom to roughly, I don't know, maybe 200 angstrom. So the particle size of the atoms here is very small, and the particle size is very small in terms of in the size of atoms or ions or molecules. So the solutions are completely transparent. What does it mean? It means when we shine, just suppose this is the light beam of light, and we've got a kind of solution of sodium chloride in water or sugar in water. When we light it, when we shine a beam of light towards this solution, we cannot see the beam of light here in the solution. So light passes through the solution without scattering. So when we haven't got any scattering, we cannot see the beam of light here. Let me explain a little bit more about the scattering of light. When we shine a beam of light to something which is very, very, very small here, we haven't got any scattering. We've got very tiny amount of scattering, so the light doesn't go into your eyes. Just suppose I'm shining a particle which is too small. The light scatters very, very, very negligible, so the light doesn't come into your eyes, so you can see it. But when we increase the size of particle, and when we shine it, the particle will scatter the light in all directions, and one of the directions is perpendicular into the surface, and it comes exactly through your eyes. And when a beam of light goes to your eyes, you can see the object, and that's why we can see the object here. And when the particle size here in the solution is too small, there is no light scatter from the particle size through your eyes, so you can't see it. It's very important to understand the meaning of scattering of light, and why when there is no scattering of light, you cannot see the particles, you cannot see the passage of the beam light. So the beam light is invisible when we are talking about the solutions. And the fourth characteristics is the solutions do not settle out. They don't precipitate. They don't cream out at the surface of the solutions, because the particles are too small again. Just suppose we've got a kind of solutions here, and the particles are too tiny, too small. So the gravity is too small for these particles, so the gravity doesn't pull them down. So there is no precipitation, sedimentation, or creaming in this case. And when the particle size are very, very small, they cannot be filtered by filter paper, because the filter papers are the whole of the filter paper are by far larger than the particle size of the atoms or ions or the molecules that I said. So all of them pass through the whole of the filter paper, so we cannot separate the solute and the solvent with the filter paper. So the filtration doesn't work in the separation of the solute and the solvent. But how we can separate out the solvent and the solute with the distillation, and we are gonna talk about the distillation in our next videos. So let's talk about suspension. Suspension is the characteristics of suspension is completely in contrast with the solution. For example, when we call the solution is a kind of homogeneous mixture, suspension is heterogeneous mixture. When we call the particle size in the solution is too small, the particle size in suspension is too large, too big, and whatever. So let's talk a bit about the suspension. Suspension is a heterogeneous mixture of large solid particles that sediments if left undisturbed. Just suppose we've got some sand in water or flour in water, or some solid particles in water, and when as long as you're mixing it, it doesn't sediment, it doesn't precipitate. But when you stop stirring it, when you left it undisturbed, the solid large particles start to sediment at the bottom of the container. So we call it a kind of suspension. So suspension, whatever you need to mix it before consumption, like some medications, they are all suspensions. So in suspensions, the main things are the particle size of the dispersed phase are too big, and because of their weight and the gravity, they will be sedimented if they are undisturbed. So it should be noted that the dispersed phase in suspension is always solid, but the dispersion medium can be solid, liquid, or gas, and we are gonna talk a bit about them a little bit later. So the characteristics or properties of suspension. Suspensions are heterogeneous mixture, so they are not uniformly distributed throughout the container, and they've got very large particles. And when we call they are very large particles, the different references provided different criteria, different size criteria. Some of them said between more than 1,000 nanometer, and some of them said it's more than 500 nanometer, and even some of them said it's more than 100 nanometer. So please consider the reference that you need to learn the problems based on them. But we usually, I consider this number as the main number because many references agrees with the large particles of larger than 1,000 nanometer as the suspension. So some large particles or some aggregates, for example, a kind of dust, even very small dust in terms of this size would be more than 1,000 nanometer. So it kind of like more than 1,000 nanometers, so they will be suspension. As a result of their big or large size, suspensions are cloudy or they are not very transparent, and they scatter light. In terms of scattering light, is really important to know, to understand that suspensions, just suppose we've got a kind of suspensions here, a little bit of sand in water or flour in water. What will happen when we shine a little bit of light to a suspension? What will happen? These large particle here will scatter the light, as you can understand, and some of the lights will come through your eyes, so you can see the passage of light into the suspension. But it should be noted that if the particle size of a suspension is too big, even bigger than this normal particle size, when it's too big, the suspension would be completely opaque and you cannot see the passage of light through them. So it's really important to know that if the suspension scatter light and you can see the beam of light, the movement of a beam of light into the suspension, it depends. If the particle size of the suspension is large enough but not too large, yes, you can see the beam of light, so the beam of light is visible. But if the particle size of the suspension is too big, too much larger than would be enough for the scattering of light, the suspension would be completely opaque, and in this case you cannot see the beam of light, so the beam of light is not visible. Another characteristics of the suspension: if you've got the suspension, as I said, the particle size of the dispersed phase will settle out or sediment or precipitate. And because the particle size or dispersed phase are too big, and it's even bigger than the whole size of the filter paper, just suppose this is the whole of the filter paper here, and the particle size are too big. Let me change the color. The particle size are too big, and this is the water. So the water can go through the whole of the filter paper and comes here, but the particle size, the dispersed phase cannot go through the hole, so you can separate the particles of the dispersed phase from the medium dispersion phase by the filtration. So the filtration can separate the particles in the suspension. So let's talk about the colloids. Colloids are the main material that we usually talk about in soft materials. It's really important to get familiar yourself with the colloid material. Colloids are a bridge between solutions and suspensions. As you can remember, I said suspensions characteristics are completely against or in contrast with the characteristics of solutions. How about colloids? Colloids is a kind of mixture which is exactly in the between solutions and suspensions. Some of the characteristics is very similar to suspensions, and some of other characteristics or properties is very similar to the solutions. For example, colloids are heterogeneous mixtures like suspensions, but they don't settle out, they don't precipitate. So in this characteristic is very similar to the solutions. So we need to get familiar by ourselves with the colloids. And it's really important to know that many materials that you can see around yourselves are colloids rather than solutions or suspensions. For example, milk is a kind of colloid, milk is a colloid. Or ice cream, or mayonnaise sauce, or paint, or jellies, or blood, smoke, dust in air, cheese, fog, cloud, whipped or shaving cream are all, some samples are colloids. As I said, colloids are heterogeneous mixture with dispersed particle size of between solutions and suspensions. It's really important to know that the size of the colloids are usually bigger than 1 nanometer and less than 1000 nanometer. As you can see, solutions have got the particle size of less than 1 nanometer, and suspensions have got the size of more than 1000 nanometer, and colloids have got the size between 1 nanometer and 1000 nanometer. And again, different references mention different particle size for colloids, so it's really important to know which reference are you talking about, are you reading the materials on based on. So try to understand and try to memorize the number between that based on that reference. So colloids are large molecules or aggregates. It's really important. For example, when we've got some big proteins in water, you know, proteins are made of amino acids, and amino acids are made of atoms or molecules or whatever. So the large is definitely bigger or larger than the size of the atoms or molecules, but they are smaller than the size of, for example, a piece of dust in water or a piece of dust in air. So they are not solutions, and on the other hand, they are not suspensions. They are colloids. So in terms of colloid characteristics, it's really important that to know that colloids are heterogeneous material, and the dispersed particles can be either solid or liquid or gas. Solid, liquid or gas. And dispersion medium can be either solid, liquid or gas. It's really important, you know, suspensions have got the dispersion particles in suspension is always solid, but in colloid the dispersed particle can be solid or liquid or gas, and dispersion medium can be solid or liquid or gas. So theoretically we've got 9 different sorts of colloids. Solid in solid, solid in liquid, solid in gas, liquid in solid, liquid in liquid, liquid in gas, gas in solid, gas in liquid, and gas in gas. So we've got 9, theoretically we've got 9 different kinds of colloids, but in practice just consider that we haven't usually got the colloid of gas in gas. So practically we've got 9 minus 1, which is 8 different colloids, and we are gonna talk about these 8 different colloids in the next video, but not in this video. And it's really important that you know that colloids scatter light, and if you've got, for example, here we've got a kind of colloid, we've got a little bit of milk in water. Just suppose we've got water and we add 1 drop of milk to this glass of water. We've got a kind of very small particles but large enough to scatter light. And when we shine the light through these colloid particles, because the particles are big enough to scatter light, they scatter, and some of the scatter light comes through your eyes and you can see the beam of light. So when you shine a beam of light, you can see the passage of light is very visible to your eyes and you can see it. So one of the most important characteristics of colloids, it's really important to understand this part, is colloids, just suppose this is a glass of water and we've got some colloidal particles. Okay, here colloidal particles have got 2 characteristics. One, in the terms of size, as I told you, they are bigger than particle size in solutions but smaller than the particle size in solutions, in suspension, sorry. And I told you about the size number, which is bigger than 1 nanometer and smaller than 1000 nanometer. But another very important characteristics of colloid particles is all of them have got a kind of surface charge that we usually call them zeta potential. And generally speaking, I'm not going to go through zeta potential surface charge in details now at the moment, but generally all of them have got some charge at the surface of the particles. For example, this one has got some positive charge at the surface, and this one has got positive charge. All of them has got similar charge. If one of them has got positive, others have got positive as well. So this positive charge repel each other, so, and the size is small enough, so because of the gravity they tend to precipitate or sediment. But because of the electrical repellence between the positive charge or negative charge in other colloidal particles, they don't precipitate. So the colloidal particles, they do not settle out or sediment or precipitate due to small particle size and because of the similar surface charge or zeta potential surface charge. But what will happen if you add an electrolyte to the colloidal system? Just suppose the very important example of colloidal system is milk. When we've got milk doesn't precipitate. So after a while, milk doesn't become in 2 different phases. There's nothing precipitated at the bottom of the container of milk. But what will happen when you add a kind of electrolyte to the colloid, or when you add a little bit of vinegar or orange juice or lime juice or whatever to a glass of milk? What will happen? When you add an electrolyte will neutralize the surface charge at the bottom. So when we neutralize the surface the surface charge on the surface of the particles, because of the gravity, these particles will sediment at the bottom or precipitate. Or sometimes when they are too less dense than water, they will cream at the surface of the container. Anyway, there will be 2 phases. So another characteristics of colloids, because of their small size, they cannot be filtered out. They cannot be the dispersed phase particles. They cannot be separated from the dispersion medium by filtration. It's another characteristics of the colloidal particles. So let's do a practice. Just suppose we've got a torch here and we are shining some laser light to sample number 1, sample number 2, 3, and 4. What will happen here? And we can see there is no visible light in this sample. What is this sample? What kind of mixture is this one? Definitely is a solution. Why? Because in solution the passage of light cannot be visible. How about sample number 2 and 3? You can see a passage of light is completely visible. So but between these two, the passage of light in sample number 3 is more visible than the sample number 2. So definitely the particle size of sample number 2 and sample number 3 are big enough to scatter light, as I told you. But in sample number 1, the particle size is too small, so there is no scattering, or the scattering is very negligible, so there is no light coming out to your eye, so you cannot see the passage of light here. But between these two, if you can see definitely this one is colloids, and this one is a suspension. Why the suspension? Why the way of light in sample number 3 in suspension is more visible than the passage of light in sample number 2 or colloids, as you can see here? Because the particle size in suspension is even bigger than the particle size in colloids. So the scattering of light in suspension is bigger than the amount of scattering of light in colloids. How about this one? This one is completely opaque system. This one is again a suspension, and the problem here is the particle size is in sample number 4 is too big, so the scattering of light is too much. The scattering of light is proportional to the size, but the scattering of light in sample number 4 is too much. But because the sample particle size of the samples are too big, this sample is completely opaque, so the light scattering is not visible in this sample. The thing that we are going to talk about in this video is Tyndall effect. As I told you in the last page, Tyndall effect is that the passage of light in colloids are visible. When you shine a colloid with a torch, you can see the passage of light is completely visible in the colloid, and we call it Tyndall effect because Tyndall was the name of the scientist who found out this scientific interaction between light and colloids. And a kind of Tyndall effect is when a beam of light passes through fog or smoke, or when a car goes through dust or soils or whatever, and in night, and the headlight is on, and you can see the passage of light is completely visible, and this is a kind of Tyndall effect. And the main important question here is Tyndall effect is solely for the colloids, or is the kind of Tyndall effect in suspensions as well? Yes, there is Tyndall effect in suspensions as well, as you can see here in this sample, but we usually call Tyndall effect for the visibility of light through the colloids. Thank you for watching this footage, and in the next footage we are gonna talk about 8 different kinds of colloids, as I told you, and mainly about the emulsions. Thank you.